Percentiles are measures of location which divide a dataset into 100 groups of approximately the same size. So the idea is if you had 100 pieces of data, you could put one piece in each of the percentiles. If you had 200 pieces of data, you would fit about 2 pieces of data in each of the 100 percentiles. That means about 1% of data values are going to be in each of the 99 percentiles. If we envision all of our data values falling on some sort of number line, we would place the 50th percentile right here in the middle. What that means is that 50% of the data falls below whatever this data value is, and 50% of the data falls above. If we break up the upper half into 2, we get the 75th percentile located here. And if we break the lower half into 2, we get the 25th percentile located here. So this means 25% of the data falls below this value, right? And 25% of the data falls above P75, whatever this value is. Up here on the high end, we would have our 100th percentile, which basically means that 100% of all the data values live below this number, right? And so we can see that we've broken this number line up naturally into 4 equal segments. Another name for these segments are quartiles. Q1 is equivalent to the 25th percentile. In other words, the first quartile is equal to the 25th percentile. Q2 is equal to the 50th percentile, and Q3 is equal to the... So quartiles break up the data into 4 equal groups, where percentiles break up the data into 100 groups. So even though I haven't drawn it here, keep in mind there is a 10th percentile, or even a 42nd percentile, or even an 89th percentile. How do we find the percentile of a given data value? Watch this video and then we'll find out.
Professor Anderson here, just finished a stationary bike ride, and I wanted to share with you how I'm always using percentiles when I'm riding this thing. So you can see here right now I finished at 56 out of 409 participants here now on the leaderboard. We can also look at the overall workout details for this ride. So overall, 54,363 people have taken this ride, and my score is 11,339. So we can use our formula for counting percentiles to figure out what percentile I'm in overall and what percentile I was in the live portion of the class.
While the method to finding a percentile can vary slightly from textbook to textbook, we're going to go ahead and use the definition from our textbook. The percentile of a data value x is found by counting the number of values that are less than x and dividing by the total number of values. Then you want to move your decimal place over 2 places, so that's the same as multiplying by 100, in order to turn your decimal into a whole number and state it as a percentile. Looking at the screen here to the left, my overall rank was 11,339. So that's the position that I'm in, the 11,339th position. But our formula tells us to count the number of ways that are less than me. So less than X, I'm X. So in order to find my percentile, we're going to take 11,338 and divide by the total number of values, which is the total number of people who took this ride. And that's 54,363. When I use a calculator to perform this division, I get the decimal number 0.2086. Now, I want to go ahead and multiply this by 100, and what that will do is that will bring this decimal over 2 places. And so now what I have is 20.86, and I'm going to go ahead and round that to nearest ones position. And so because of this 8 is bigger than 5, it means I'm going to round this 0 up 1. So I'm going to round this up to 21. That means that my speed, or output actually, for that ride put me in the 21st percentile. So in other words, 21% of all riders who took this workout earned a total output that was higher than mine of 344, and then the remaining 79% earned a total output that was less than mine, less than 344. So another way I could phrase this is you may hear it stated as the top 21%. So I am in the top 21% of people who completed this ride. To practice the technique of finding percentiles one more time, let's look back at my rank on the leaderboard during my actual ride. So 54,363 people took the ride, but when I took it, there were currently 409 people taking the ride, and I finished here in 56th place. So again, my position is 56. So in order to find the percentile, I'm going to count the number of positions below me, which is 55, and then I'm going to go ahead and divide that by 409, which is the total number of people taking the ride at the same time that I took it. And so in the calculator, that gives me the decimal of 0.1345. And so again, I multiply that by 100, which moves my decimal over 2 places. So I end up with 13.45. And then we'll round here to the nearest whole number, which is going to be 13. So this represents the 13th percentile, or you can say P13 is defined by 55. In other words, a rank of 55 defines the 13th percentile. Let's look at this process in the other direction. Suppose we are given a list of data and we want to find the position that a certain percentile is located in. So suppose we're asked to find the 80th percentile for this set of GPAs. Intuitively, we know that the 50th percentile is going to be in the middle of this data set. So anything below the middle is in the 50th percentile, and anything above would be higher than that. So the 80th percentile we know is going to be, somewhere between the 50th and the 100th percentile, if you will. So, maybe somewhere up here. But in order to get that exact location, what we need to do is we need to calculate the location on the list where the 80th percentile lives. So the formula that we use for making this calculation is to take k, where k is the desired percentile, and multiply that by n, which is the total number of data values. In our example, 80 is going to be k, so 80 over 100 really gives us that decimal 0.8, and then we're going to be multiplying by n, which in this case is 14, because we have 14 data values. And so 80 over 100, again, really that just represents 80%. And when we multiply these two numbers together, we get 11.2. So here's the rule when finding the location on the list. There isn't such thing as the 11.2 position, right? We just know it's somewhere in between the 11th and the 12th position. Now, what we're always going to do, even though conventional rounding rules tell us that we should take, because of this 2 right here, we should round down to 11, we are always going to round this number up. So it doesn't matter what decimal value you have, we're going to round this number up to get our location on the list. So we're going to round that up to 12. So we're going to look at the 12th position on the list, which is 3.9 right here. And that is going to be our 80th percentile. Let's practice this one more time and find the 50th percentile. So that means that we're going to be taking 50 over 100 and multiplying by 14 in order to find the position on the list that defines the 50th percentile. So we end up with a whole number in this case. We end up with the location on our list being the 7. But when we have a whole number and not a decimal, like the last example, the method that we're going to use to find this percentile value is to take the 7th and 8th positions. So the numbers in both of those positions and average them together. So if we count up to the 7th position, 1, 2, 3, 4, 5, 6, 7, this 3.2 is in the 7th position and 3.3 is in the 8th position. So we're going to take 3.2 plus 3.3, divide that answer by 2, divide that sum by 2, and we get 3.25. So a GPA of 3.25 defines the 50th percentile. So it's okay that that number is not actually one of our data values. What we're saying is that the 50th percentile would be defined by that GPA.